The next thing we're going to talk about is something that always used to make me nervous, right? I was famous in high school, in college, and in grad school for being able to figure out things, and then the second that a metric conversion came around, I would always move the decimal point the wrong way. So what I've done is I beat the heck out of myself until I figured out a way that would always work for me. I'm going to teach that to you. There's a bunch of different ways to do these metric conversions, and you may hate mine. That's fine. Just don't tell me because I cry easily. So the way that we're going to talk about metric conversions, we're actually going to take the kind of the upper portion of that resource guide, the metric conversion guide that I posted as on Canvas, and we're just going to take those, and I'm going to show you exactly how I do kind of the more simple version and then the slightly more complex metric version. And just as kind of an aside, if you don't think this is important, it really can get important, especially those of you going into like a health field or something like that. I used to work on an ambulance, and I can remember vividly being in like this ER with like this pediatric patient that was, basically dying in front of us. And like a doctor actually, one of the ER docs had drawn up like this crazy amount of this drug that was based on a wrong metric conversion. And, I was just a paramedic student at the time. I was like, that ain't right. So anyway, this is like something, if you learn it, like you can really do some good things with it. Yeah, enough of that. Okay, so let's take a look at the very first problem. All right, so this very first problem, we're going to take 3.4 liters and we're going to convert that thing to milliliters. A lot of you are going to say, I can do this in my head. And I'm going to say 50% of the time you're probably going to be right. So I'm going to teach you a fail-safe method that'll work for anything for this particular problem right here. It's called unit conversion, or some people call it dimensional analysis. It's taught in a lot of the math classes here. Really useful technique. But you kind of got to bear with me a little bit for just a second here. Incidentally, you should probably have already watched the metric system video lecture that I put out there. Hopefully by now you understand that we always have base units in the metric system, because this method is really going to depend on you being able to recognize a base unit. Liters, base unit for volume. There's a prefix, and then there's the base unit again, right? And just remember, prefixes modify the base unit. And there's a resource guide that you're always allowed to use on exams and stuff like that that's available on Canvas. So how are we going to do this method? Well, first thing that we're going to do is we're going to take wherever we're starting and put it over 1, right? The good news is there's no there's not a miles per hour or anything like that, or liters per minute or anything like that. So we can just put this sucker straight over 1, and it doesn't change anything, right? It's still just 3.4 at that point. All right, 3.4 liters over 1. The very next thing to do is really important. We're going to put a little dot that represents multiplication, all right? We're going to leave a bunch of space, and we're going to put an equal sign, and this whole entire method depends on you keeping track of units, right? The numbers come later. The units are the most important things. So what we want to do is we want to, next to our equal sign here, I didn't leave myself much room, I want to put a milliliter. That is going to help me in this crazy world. In this conversion, it's not so bad, but we are going to be seeing calculations where we're going to feel like we're going through multiple steps and all over the place. It's really easy to get lost. Maybe not on this problem, but for future ones, right? So that is kind of like my shining light, right? There's a light at the end of the tunnel, and it says milliliters. You want to go there, right? Go towards the milliliter light. And so no matter what conversion that I put here, right? And by the way, we're going to talk about conversion factors in just a second. It better frickin' somewhere have liters, and it better somewhere have milliliters. And the numbers that I put with those prefixes have to be right? So the way that we're going to do that is the following method here. Okay, so I am going to put what's called a conversion factor in here. this thing is called a conversion factor. What must be true of your conversion factors is they must be true. In other words, it's really important that you recognize that this thing is, equal to unity, right? It's a true statement, right? Whatever I put over this thing, I'm essentially going to be multiplying by 1 here, right? But I'm going to be throwing some units in there that makes it look a little bit more confusing. So we're going to keep track of units, not going to think about numbers at all. Put down your pen if you start writing numbers. Stop it. What we're going to do is we're going to say, okay, there's a liter. I want liters to go away on my way to milliliters, right? Notice that all I have written there are units. I'm not thinking at all about numbers or what's equal to what yet. Okay, I'm going to look at that. I'm going to see prefixes. I'm going to say, is the base unit there? Well, yes, there's the base unit. In other words, I can't have a conversion factor in this method that has prefixed units, right? Only prefixed units. So I see a prefixed unit. And there's my base unit. That's good stuff, right? Turns out, as long as you have a base unit using this method in your conversion factor, you can put 1 with the prefixed unit. I'm going to say that again. Where does 1 go? 1 always goes with the prefixed unit. 1 goes with the prefixed unit. What's the prefixed unit? It's the unit with the prefix, not the base unit. It's the other one. If you ever put a 1 in this method with your base unit, you're going to get it wrong. Every time, right? And keep in mind, there's 1,000 different ways to do this. I understand that. If you feel good about a method where you can violate that consistently, awesome. I would say 90% of you, though, should follow this. Exactly 10% of you will, but you'll get it right. So the 1, we're going to put a 1 right there with the prefixed unit. The advantage of this is the second that you recognize where the 1 goes, the other number is going to come from your metric system guide, and if I'm skilled enough, I'll have a little picture appear of the metric system guide, somewhere around here. And whatever number is on that thing, we're going to enter that number in here. Okay? So when you look at your metric system guide, you will see that 1 milliliter is equal to 10 to the negative 3rd liters, right? So right now, go to your metric guide, find milli, and milli has a little 10 to the negative 3 written on the far right column. You could have also put that, instead of that, you could have just put 0.001. That's the exact same thing as saying 10 to the negative 3rd. Okay? If you don't like exponents, and I've had students that just said, no, I'm never using exponents, awesome, who cares? As long as you get the right answer, I couldn't care less. I like to save space and time because I'm a lazy man. So I'm going to write it like that. Okay, so at that point, you grab the handy dandy calculator or that online calculator that I posted. If you don't have a scientific calculator, we're going to enter that in 3.4 liters divided by 10 caret negative 3. And what we're going to find, and let me redraw it down here, is that there's a couple of different possibilities for what your calculator pops out. Your calculator, if it's set up in the form of scientific notation, may look something like this. It may say 3.4 times 10 to the 3rd milliliters. That's one possibility. That is probably the best possibility because you don't have to do any thinking after that. For instance, the one online, though, won't actually say that. A lot of calculators don't say times 10 to the 3rd. What it'll look like in calculator land will be 3.4 E3. That's what I call calculator speak. That number right there, written in calculator speak, is just the way that we represent scientific notation. Oh geez, I better put units on there. Sorry about that, everybody. Don't throw anything at me. Luckily, this is virtual. Right? The important thing is, on exams and stuff like that, don't write the E, right? Don't be a calculator. Don't be a dork. If you're going to have to wear like horn rim glasses and stuff like that, hike up your pants. Actually, that might be a good look for the next video. But, you know, don't use the E. Recognize that where I see an E, it's times 10 to the blah, 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 right? Some of you don't have a scientific calculator. You plug it in, and what is it going to do to you? Well, it's going to say your answer is 3,400 milliliters. I don't care between these two numbers how you express it, unless in the actual exam question, sorry, celebration of knowledge question, does it say you need to write your answer in scientific notation, or you can write your answer however you want. You know, for this problem, I don't care. As long as you get the answer right, it's all the same. Okay, another metric conversion that goes either to or from a base unit in the metric system. This one is grams, a measure of mass. That's the prefixed unit, that's centigrams. So when we set this up, we're going to set it up in the exact same way at the start. We're going to take our number with the units and put it over 1. We're going to put our conversion factor right here. We're going to do our equal sign, and we're going to say, okay, where are we going? All right, I got it all set up. So if you looked at the last video, remember, don't think about numbers right now. Think only units. And then we're going to be mindless automatons. We are going to say, centigrams, I want you to go away. I'm going to put centigrams down there to get rid of you. I want to go to grams. Grams on the top, centigrams on the bottom. You're going to get to this, and you're always going to say, 1 goes with the prefixed unit. What is the prefixed unit? I look. Oh, look, there is a prefixed unit. That is a base unit. 1 always goes with the prefixed unit. There we go. 1 centigram. What is the number that I used from my sheet? It is 10 to the negative second. All right, that is set up perfectly. Turns out, you know, a lot of you folks probably learned a method where you use, like, you know, the 1 doesn't go with the prefix unit. Don't do it. It has made so many students want to cry in my office. Don't do that, please. Just do 1 with the prefix unit, for the love of God. Okay? Awesome. Centigrams are going to cancel out. I guess I should have done that in the last slide too. Sorry about that. We're left with grams. And so now we have got 0.9 times 10 to the negative second. You can enter it into your calculator if you want to. And your calculator will either give you something that looks like this. Right? Keep in mind the weird thing about scientific notation, you always have to have a whole number digit right there. So we've got something 9 times 10 to the negative third, or the other way that it could be written, one, two, three. Both of these are the same exact number. Right? Important thing is that you don't fall into the trap of being me back in the day, where it's just like, I'm just going to move a decimal point. Woohoo! It's fun! Because you will always move it in the wrong direction. But with this method, you will never do that. This next problem is a little bit more of a spicy meatball than the last problem. And the way that I know that, just kind of by looking at it quickly, is you'll notice that there are no base units present here, just plain old base units without prefixes, I mean, right? So there's no meters there, right? There's only kilometers and centimeters. So a prefix to another prefixed unit, turns out we're going to have to add one more step to our conversion factor, but it's still super easy, okay? And 1 is still going to go where? I won't tell you. It's with the prefix unit. I guess I did tell you. Okay, so we're going to start things off. We're going to put 45 with the units. Put that sucker over 1. We're going to give a big, giant space. And we're going to say, where the heck are we going? We want to go to centimeters. And what we're going to do is we're going to put 2 conversion factors in here. Turns out that's kind of the one extra step of a prefixed unit to another prefixed unit. We're still going to be brainless automatons, and we're going to look at kilometers, and we're going to say, I want you to go bye-bye, so I'm going to put kilometers down here. The problem is that if I just put centimeters up here right now, that requires me to think. I can't just use the sheet that I'm telling you to use, right? So we're not going to go directly to centimeters because you will screw it up. I promise you, you will screw it up. Instead, what we're going to do is we're going to go to the base unit first, right, which is meters. And then, in this next conversion factor, we're going to be brainless automatons again, and we're going to say, where does meters go? Meters goes down here to cancel out. Where are we going to centimeters? Okay. Notice now I have 2 conversion factors. Both of those contain the base unit. And so now I can do that. One goes with the base unit. Sorry. I can't believe I just did that. One goes with the prefixed unit. So I am not going to think about numbers, not going to look at the sheet. I'm just going to simply say, which of these is the prefixed unit? Everybody yell, kilo is a prefixed unit. Right here. Where does the prefixed unit go? Even my son is yelling upstairs. He must hear this and be really excited like you. 1 goes with centimeters. And now the brainless automatons are allowed to look at our sheet. And what we're going to do is we're going to recognize in 1 kilometer we have 10 to the 3rd or 1,000 meters. We're going to look at our sheet and say 1 centimeter is how many? Okay, 10 to the -2nd meters, right? Not too shabby. Now we're going to enter all this crap into our calculator, and what we'll end up with are 2 numbers, one over the other. That's, by the way I would do it. A lot of people like to plug everything into their fancy-dancy calculator, and they almost always screw something up. So what I like to do is the top times the top times the top, bloop, bottom times the bottom times the bottom, bloop. And then I do this operation in the last step. That's something that a lot of people don't like to do. They just like to plug it into their fancy-dancy calculator, but that often results in errors. So this is just kind of one of those things through experience that I've started to do. So we're going to do exactly that. We're going to look at this, 45 kilometers times 10 to the 3rd. And just for fun, I'm not going to write it in scientific notation. I'm just going to write it out as 45,000. Because that's most likely number to pop up when you enter that into your own calculator. And then I don't have to do anything to the bottom just yet. So now what I'm going to do is I'm going to enter 45,000 over 10 to the -2nd. And then what is going to appear but the fact that we've essentially added 2 zeros to this thing. Or alternatively, oh geez, I always forget my units. Alternatively, you may see 1, 2, 3, 4, 5, 6 pop out of your calculator. One more try with this thing, another prefixed unit to prefixed unit metric conversion. This one is probably going to, if you're good at math or good at this, using my method for this is going to make you feel kind of weird because like we're kind of going from one pretty small prefix unit to another pretty small prefix unit. If you don't know what the hell I'm talking about, don't worry about it. So what we're going to do is we're going to start off the same exact way. That number over 1. We're going to go to equals. We're going to recognize that this is a prefix unit to prefix unit kind of calculation. And so that reminds me that I actually need 2 conversion factors. you don't need to know that in advance. You can kind of just let the prefixed units tell you that eventually. In that case, just leave a huge space anytime you do a metric conversion. And that might be a kind of an easy thing to do at the start. So we're mindless automatons. All right, hopefully that makes sense to everybody. Now we figure out where the ones go. Ones go with the prefixed unit. And now we just have to read our sheets to figure out what power of 10 does that prefixed unit modify a grand by. We've got 10 to the negative third there, 10 to the negative 1 there. Of course, we could just write 0.1, but I like exponents. So we can plug all this into our calculator, and we'll end up with one number over another number. Let's see, so 1, 2, 3. Hopefully I didn't screw that up with my board brain issue. And then we've essentially got that thing over 0.1, and we enter it into our calculator, and what hopefully will pop out is either that value, or if you have it set up to do scientific notation, I'll just for fun put it in scientific notation. But scientific notation is actually more cumbersome in that case, but that's what it would look like. So I hope you guys were able to make some sense out of these metric conversions. In my experience teaching this class, this can be something that's really challenging. So what I've done is I will post the answer key to this entire thing, including exactly how I set it up in this method. I would not look at it until I've kind of tried a couple. Yeah. And so like this is something you can do your whole entire career. And it actually works for a bunch of other, not just metric to metric conversions, but any conversion. And that's kind of what we'll start talking about in a future lecture.